Okay, so the final topic we have to cover in maths methods is the normal approximation to the binomial distribution. Now, when you vary n and p for the binomial distribution, what you get is different looking curves. And if you skew it left or skew it right, you produce obviously weighted results to this side or this side. But if the probability of success is 0.5, then generally we get this curve that looks much like an early approximation of the normal distribution. And actually, if we increase n, so here's an example of n equals 100 and p equals 0.5, we actually get a really good normal distribution curve, or very close to the normal distribution curve. So in summary, what we note is that the binomial distribution depends on n and p. And if n is small and p is close to 0 or 1, we get a skewed distribution, but otherwise it's pretty symmetrical. Okay, we get a pretty symmetrical distribution. And if n is large enough, what we get is a skew that's not too great, and thus the normal distribution can be used as a reasonable approximation. It's not exact, but it's reasonably close to the binomial distribution. The approximation is generally better for larger n and when p is not too close to either 0 or 1, if it doesn't lean too close to either side. So in summary, if n is sufficiently large, the binomial random variable x will be approximately normally distributed. Again, it's worth noting approximately, with a mean of n times p and a standard deviation of np, 1 take p, all square rooted. Now again, for 2020, these are on the formula sheet, albeit this one here is written as sigma squared without the square root sign. And how to know whether you're safe to use the normal approximation? Well, NP and n multiplied by 1 take p must be greater than 5 for a satisfactory approximation. Anything less than that, and it means we've got some sort of skewed distribution. It's just not enough trials, or it leans too far to the left and right for it to be considered a reasonable approximation. Right, so here's a question that we can possibly do this on. So a sample of 1,000 people, that indicates that we've got n equals 1,000. From a certain city, we're asked to indicate whether or not they were in favour of the construction of a new freeway. It's known that 30% of the people are in favour of the new freeway. Find the approximate probability that between 270 and 330 people in the sample were in favour of a new freeway. So they want the approximate probability, okay? Not the probability to 3 decimal places, the approximate. So they're asking for an approximation. All right, so here goes. I know that we've got a binomial distribution. A random variable is binomially distributed with a probability of success of 0.3 and 1,000 trials. So 1,000 trials, 0.3. That means my mean is 0.3 times 1,000, which is 300. And what we can do now is get the standard deviation. So sigma squared equals np, 1 take p from the formula sheet, which is equal to 1,000 times 0.3 times 0.7, which is 210, which means that our standard deviation is square root of 210. All right, so they want the approximate probability. So what I'm going to do is I'm going to get the normal approximation of the binomial. Okay, so to do that, I'm going to go over to interactive and go to continuous and norm CDF. All right, what I'm going to do is go a lower rather of 270. My upper is 330. I've got a standard deviation of shift root 210 and a mean of 300. All right, let's see what it says. Okay, so the norm approx of the binomial is norm CDF 270, 330, 210, 300, 0.961 5, 6, dot, 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 dot. So find the approximate probability that it's between 270 and 330. We're going to suggest that it is roughly there according to the normal approximation of the binomial. Now we can also get the actual binomial approximation, binomial probability. So we can actually use this over here to work it out. So I'm going to get the actual one, so the actual probability, which recall we go to discrete and binomial CDF. Now my lower is 270, my upper is 330. We're doing this 1,000 times and the probability of success is 0.3. Now what should happen is that this value that we work out here should be pretty close to this. It's not going to be exactly the same, but it's going to be pretty close. Okay, so compared to, so this one here is binomial CDF 270, 330, 1,000, 0.3 equals 0.96475 dot, 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 dot. All right, so it's not the same, but it's pretty close. And the reason it's pretty close is that we're safe to do this. Now, why do I know that we're safe? Well, n times p, so recall the rule of thumb test, np must be greater than 5. So n times p equals 300, and n multiplied by 1 take p is equal to 700. So 300 is greater than 5 and 700 is greater than 5. So therefore we can conclude normal approx is okay. All right, now how to know whether you're allowed to use it or not, or whether they're looking for the binomial or they're looking for the normal approximation. Well, I've seen it actually just asked flat out using the normal approximation, or alternatively, I've actually seen them say something like, do not use the normal approximation. But I think in this question anyway, the fact that they say the approximate probability rather than find the probability means that they're permitting us to use the normal approximation. Okay, so that's what to look for, is whether it's formally stated, okay, or words like approximate probability are also acceptable. All right, and with little fanfare, I suppose, what we've hit, girls, is the end of the methods course. Okay, that is it for maths methods. I've queued up a little Spotify song here to play. So here goes. If you can imagine me dancing around at the moment after recording this video. All right, so that's methods for 2020. And it's been a rough year. We've had less content to cover, but certainly our own challenges with working remotely. So the work that you'll need to do now is finish off 16E. It's only a couple of questions. Do the chapter review and get knee deep in exams. Okay, that should be your focus, girls, is on exams. Good luck with it. I'm here to support you.